Okay, good morning, my dear students. So today we will discuss about the fundamental rotation matrices. Fundamental rotation matrices only. So without translation, only rotation is happening between two frames. So that matrices we are discussing in this class. Okay. So for example, a frame two, which may be rotated about one or more of the principal axes or any arbitrary axis or by some fixed angles relative to frame 1. So these are the matrices will be happened in between the frames 1 and 2. Okay. So first let us discuss. So when the frame 2, which is rotated about principal axis. So later I will discuss about the rotation about fixed angle relative to frame 1, arbitrary axes, etc. Okay, so principal axis rotation. So it means that to determine the orientation of frame 2, which is rotated about one of the three principal axes of the frame 1. Okay, about the principal axis frame 1. So we are going to determine the orientation of the frame 2. Okay, for example, we take the rotation of frame 2 with respect to frame 1 by an angle theta about the z-axis of frame 1. Okay, about the principal axis z-axis of frame 1. So this is the example. So for this, let us see what is the rotation, fundamental rotation matrix. Okay. So here is the small note you observe. So in this example of rotation, it is previously denoted as 1R2. Okay, it is previously denoted as 1R2. So it means that rotation of frame 2 with respect to frame 1. That is the meaning. Okay. So which is also denoted by the symbol. Okay. So for this example, so the rotation matrix symbol, it is about z-axis, about principal axis of frame 1, about z-axis by an angle theta. The frame 2 it is rotated. Okay. So this is the symbol we are using in this fundamental rotation matrices. So similarly, or else so this is the symbol, or this is also a symbol of same meaning. So rotation about z-axis by an angle theta. So this is also same. Okay. So let us look at the figure, which exactly shows the rotation of frame 2 about z-axis of frame 1 by an angle theta. So here in this example, you see, if you observe the axis of Z and axis of the W of frame 2, which are exactly coincident. Okay. So between x-axis and U, so there is an angle theta, and similarly between Y and V, there is an angle theta, because about z-axis, the second frame is rotated. Okay. So initially, both the frames axes are coincident, are in the same axis, XYZ and UVW are in. After rotation about z-axis, the second frame, which is splitted from the frame 1 to the new position, okay, by an angle theta. Okay. So let us see how to write the rotation matrix for this example. So R suffix Z of theta is computed from the dot product of, so rotation matrices which are happened by the dot product of unit vectors, so along the principal axis, that is x bar, u bar, u. what is the dot product of any two vectors? It is simply multiplied by the magnitude of their vectors. So, for example, by dot product of x vector, x unit vector and u unit vector, which is equal to, so mod of x bar into mod of u bar cos theta. So where theta is the angle between x and u vectors, Okay. So for the rotation matrix about z-axis, so this is the matrix. So this is the cos theta, angle between x and this theta, angle between x and u. So you cos 90 plus theta. So this 90 plus theta is the angle between x and v, So this cos 90, so angle between x and w. Okay. So similarly, you write all the elements in this matrix. Okay, cos 90 minus theta, cos 90, cos 0. Okay. So about z-axis, so there is the rotation matrix in terms of theta. So cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. So this matrix, it is in simple form. You write in simple form. So here, c theta, it means it is cos theta. S theta is it means sin theta. So similarly, so now let us write. So this matrix about z-axis by an angle theta. So similarly, if you want to write a rotation about x and y axis by an angle theta. Okay, so rotation by an angle, rotation about x-axis, about principal x-axis by an angle theta. So this is the matrix. So 1, 0, 0. So 0 cos theta minus sin theta. So 0 sin theta cos theta. Okay. So say about y-axis by an angle theta. So this is the matrix. Cos theta 0 sin theta 0 1 0. So minus sin theta 0 sin theta. So if you observe these three matrices about x-axis, about y-axis, about z-axis. So there is a common pattern we can follow to write these rotation matrices. So what is that common pattern? So let us see. Okay, so the rotation matrix for rotation about a k principal axis. So Rk of theta can be obtained as follows. Okay, so here are the three steps we follow to write the rotation matrix. So in the first step, so the elements of ith row and ith column. So for I is equal to 1, 2, 3. For k is equal to x-axis, about y-axis, about z-axis, respectively, of 3 by 3 matrix. So the rotation matrix about k by an angle theta are 0 except the element ii, which is 1. So for example, so let us consider I is equal to 1. So k is equal to x. K is equal to x. So it means that rotation about x-axis, ith column, ith row. So ith column, ith row value is 1. So except this ii element in the matrix, so the remaining elements are 0 in that row and column. For instance, if you observe this matrix, so I is equal to 1. So I is equal to 1. I is equal to 1, 2, 3. So k is equal to x. Okay. So this is ii element. So this ii element value is 1. Okay. So here, first row, second column. So 1, 2 elements. 1, 2 element 0, 1, 3 element 0. So similarly, 2, 1 element 0, 2, 3 element 0. Okay. So next to second step, the other two diagonal elements are cos theta. So in this matrix, uh, uh, so one diagonal element is 1. The other two diagonal elements are cos theta and cos theta. So next in third step, you write the other non-diagonal off diagonal elements. So these two are off diagonal elements. So off diagonal elements are sin theta. So this minus sin theta, it is in I plus 1th row. So the off diagonal element here is minus sin theta. So in I plus 2 eighth element, so this is sin theta. Okay, so these two are in cyclic order. Okay, for example, if you consider so this matrix about y-axis. So about y-axis, so the diagonal element 1, which is 2, 2. I is equal to 2. Second row, second column. So this is 1. So the other elements in this row and column are zeros. Okay. So the other diagonal elements except I, so cos theta. So other off diagonal elements. So here, so this is I at I is equal to, so this is I is equal to 2. So I plus 1, this row is I plus 1. So I plus 1th row. So in this I plus 1th row, the off diagonal element is minus sin theta. So this row is I plus 2. I plus 2th row. So in this I plus 2th row, the off diagonal element is sin theta. So similarly, you observe third rotation matrix about z-axis. Okay, so about z-axis. So this is ith row. So this is ith row and ith column. So the element is 1. Ith row and ith column. So the element is 1. So the I plus 1th row is, so this one. So this one is I plus 1th row in a cyclic order. So this row is called I plus 1th row in cyclic order. So in this I plus 1th row, the off diagonal element is minus sin theta. So this is I plus 2th row. So I plus 2th row. The off diagonal element is sin theta. So the diagonal elements are cos theta at 1, 1, cos theta at 2, 2, and cos 1 at 3, 3. At 1 at 3, 3. So in this way, we are writing the fundamental rotation matrices. Fundamentally, it is a easy way. If you compatible with the pattern of writing rotation matrix, so it is the easy way to write rotation matrix. So now let us write homogeneous transformation matrix for the above rotation matrices, and also assume so translation vector in this transformation homogeneous transformation matrix, translation vector is 0, 0, 0. Okay. So it means that pure rotation. How to write the transformation matrix? So for example, so let us take homogeneous transformation matrix about x-axis by an angle theta. So this is this 3 by 3 matrix, it is a fundamental rotation matrix about x-axis. So this is the translation vector 0, 0. So this is the fourth element. So similarly, write homogeneous transformation matrix about y-axis and z-axis by an angle theta. Okay, so this is about y-axis. So simply you write 3 by 3 matrix. So whatever the 3 by 3 matrix we have obtained the above. So just simply write that 3 by 3 matrix in this homogeneous transformation matrix. So about z-axis, so this is the rotation matrix. In these 3 homogeneous transformation matrices for all 3 matrices, so translation vector is 0, 0, 0. Okay. Next, multiplication of rotation matrices. Suppose in a one case, the frame 2, which is rotated 2 times, say about one axis by an angle, by some angle. So about another axis by an angle, by another angle. So in that case, so how to get the overall rotation matrix? So overall rotation matrix when the frame is involved in 2 actions or 3 actions, so or 4 actions and so on. So okay. So here let us take an example. So how to write the overall rotation matrix? So in this case, so overall rotation matrix we are going to write for the case of a rotation of an angle theta 1 about x-axis, it is a first action. So it is followed by a rotation angle theta 2 about y-axis. So these are the 2 actions on frame 2. Okay, with respect to the frame 1. Okay, so while writing overall rotation matrix R is equal to, so here in this equation, so two actions. So last action in the case. Okay, so this is second action. So in general, it is a last action. So the last term in this equation, it is first action of the case. It is the first action of the case. Okay. So suppose here are 2 actions only. So for the 2 actions, the second action is first in this equation. The first action is last in this equation. Okay. For example, in a case, so rotation of the frame 2, it is happened. So more than 3 actions, So for example, 4. So for example, 4. So fourth action, if you write when we write the overall rotation matrix, so the fourth action write in this equation at the first. So the last term in this equation, it indicates the first action of the case. Okay. So in this way, you have to do. So here, while calculating overall rotation matrix, we need to follow the order of multiplying the rotation matrix. It is very clear. So it is, you have to follow this fundamental rule. So while multiplying the rotation matrix. So otherwise, the result may not be correct if you change the order of the matrices. Okay, so therefore R is equal to, so this is, so rotation about x-axis by an angle theta 2. So this is rotation about x-axis. So this is rotation about y-axis by an angle theta 2. This is about y-axis by an angle theta 1. So if you multiply these two matrices, the result will be overall rotation matrix. It is like this: C2, S1, S2, C1, S2. So here, where C1 is the cos theta 1, S1 is the sin theta 1, C2 cos theta 2, S2 sin theta. Okay. So here is the one note. So this matrix product is not commutative. It's not commutative. So therefore, so the sequence of multiplication of R matrices are very important. Okay, so which are very important. The sequence of multiplication of R matrices we have to follow. And if there is a different sequence, if you write, so the result you may get wrong. Okay. So let us do one numerical problem on this concept. Okay. So a rotation of angle 45 degree about x-axis, followed by a rotation of angle 60 degree about y-axis. So determine overall rotation matrix. So the equation, it is R equal to rotation matrix about y-axis by an angle 60 multiplied by rotation about x-axis by an angle 45 degree. Okay. So what is the matrix about y-axis? It is by an angle say 60. Cos 60, 0, sin 60, 0, 1, 0, minus sin 60, 0, cos 60. So therefore, so this is the matrix. Cos 60 is for 0.5, sin 60 is 0.866. So about x-axis by an angle 45 degree. So it is 1, 0, 0, 0, 0, cos 45 minus sin 45. So 0, sin 45, cos 45. Okay, so cos 45 and sin 45, their values are 0.707. So now overall rotation matrix is product of these two matrices. So this is the result. Okay. So in this way, you will get overall rotation matrix. So let us do another problem on the same concept. So multiple rotations of a frame. Multiple rotations of a frame. So here are three rotational actions are happened in this on the frame 2. Okay, so let us read the problem. Okay, frame 1 and frame 2 have coincident origins and differ only in orientation. Okay, so frame 2. Initially, it is coincident with frame 1. So it means that all axes, frame 2 axis and frame 1 axis are coincident initially. Okay. So here are certain rotations are happened about the axis of the fixed frame 1. About the axis of the fixed frame 1. So the first rotation about x-axis by 45 degree. So then about y-axis by 30 degree, and finally about x-axis by 60 degree. Okay, so here are three actions. So first action is about x-axis by 45 degree, about y-axis, second action about y-axis by 30 degree, and final third action about again x-axis by 60 degree. So let us find the equivalent rotation matrix or overall rotation matrix. So 1 or 2. 1 or 2. Okay. So as I mentioned about in the mathematical relation, we write the equivalent rotation matrix 1 or 2 is equal to. So first we write the first term, it is last action. So last action in the problem. So that is Rx about 60 degrees, last action. And next followed by this action about y-axis 30 degree, and followed by the first action about x-axis by 45 degree. So in this sequence, we have to write the rotation. Okay, so about x-axis by 60 degrees. So this is the matrix. About y-axis by 30 degrees. This is the matrix. About x-axis. This is the. So after multiplying these three matrices, so this is the overall rotation matrix. Okay. ఇక్కడ మీరు గుర్తుపెట్టుకోవాల్సింది ఏంటంటే ఇక్కడ రొటేషన్ మ్యాట్రిక్స్ ఈ ఆర్డర్ అయితే మీరు కంపల్సరీగా ఫాలో అవ్వాలండి అకార్డింగ్ టు ద రూల్ matrix multiplication rule. So we have to follow the sequence of arranging the matrices in sequence. Okay. So let us go to the another slide. Okay. So the above topic is principal axis rotation. So now the other topic here. So fixed angle representation. Fixed angle. So rotation which is happened by fixed angle. Okay. Fixed angle representation. Okay. So first let us read this paragraph. So here the frame one is fixed, that is XYZ. Okay, XYZ. These XYZ are called principal axis. Okay, and there is a moving frame. Frame 2 is a moving frame, which is UVW. So you assume initially they are coincident. Initially they are coincident. So now let us consider the sequence of rotations about the three axes of fixed frame. About the three axes of fixed frame. Okay. So first, moving frame 2 is rotated by an angle θ1. It is a fixed angle about x-axis. With about x-axis, to reach the new position of frame 2, it is 2' frame. So I will show you in the figure. So this is 2'. After rotation of frame 2 about x-axis by an angle θ1, the frame 2 it occupies the new position as that frame is called a 2' frame. Okay. So this rotation is described or denoted as Rx of θ1 as a symbol. The rotation matrix like this you have to fill. So next, second action, the frame 2' is rotated. The frame 2' is rotated by an angle θ2 about y-axis. About y-axis. So this about y-axis, it is a again a fixed frame y-axis by an angle θ2. You rotate the frame 2'. Okay. So it gives out the frame 2 dash, it occupies new frame, that is 2 double dash. Okay, 2 double dash. Okay, so this rotation is described as Ry of theta. So finally, it is rotated by an angle theta. So here it means that frame 2 double dash, frame 2 double dash is rotated by an angle theta 3 about z axis to frame 2 to reach the final frame 2. So as in figure. Okay. So this rotation is described as Rz of theta 3. Okay. So let us look at the figure. Okay, you remember these three actions. Okay. So in three steps, we are reaching the orientation of the final frame 2. Okay. So in the first figure, so initially let us assume frame 1 and frame 2 they are in coincident. Okay. So in the first action, so let us what is the first action? Rotate frame 2 about x-axis by an angle theta. So by an angle theta 2 in anti-clockwise direction. Okay. So here, so x and u dash axis are coincident. Okay. So y dash, z double dash. So they are rotated by an angle theta. Okay. So this frame u dash this is v dash. U dash, v dash, w dash. It is the frame 2 dash. Okay. So this 2 dash, this 2 dash frame is an arbitrary frame. So here actually original frames are 2 only. So first frame and second frame. So the frames which are involved intermediately, so those frames are arbitrary frames. We are assuming the arbitrary frames, okay, by each rotation. Okay, so this is the first case. And the second, if you observe this figure, so in this figure, now we have to rotate second dash frame, we have to rotate second dash frame about y-axis by an angle theta 2, about y-axis of first frame. So this is, okay. So this is the rotation by an angle theta 2. Okay, so from 2 dash frame to 2 double dash frame. Okay, I think you observed this thing. So this is the rotation from W dash to W double dash, from B dash to B double dash. This rotation is theta 2. No, finally, okay, so you observe this figure. So rotate 2 dash, 2 double dash frame, about z-axis of frame 1, after rotation by an angle theta 3 about z-axis. So the axis UVW will reach the final frame 2. Okay, so destination frame 2. Okay. So in this rotation, there are this is the case of fixed angle rotation about principal axis XY Z. So let us see what is the overall rotation matrix. So this is overall rotation matrix. 1 R2 is equal to. So here last action is first. So first action is last. Okay. So this is intermediary action. Say about z by theta 3, about y by theta 2, about x by theta 1. So this is also represented as or denoted as r x y z, r x y z, theta 3, theta 2, theta 1. Okay. So first action about x, y, z, theta 3, theta 2, theta 1. So about that theta 3, theta 2, theta 1. So this rotation altering right to left, from right to left. Okay, so these are the three matrices. After multiplying these three matrices, so this is the overall rotation matrix. So it is an equivalent rotation matrix. It is used for all for any kind of rotation which involved in three actions. Okay, so you read this paragraph. So the final frame orientation for any set of rotations performed about the axis of a fixed frame, so can be obtained by multiplying the rotation matrices in a consistent order as indicated above. Okay, so in fixed angle representation, so the order of rotations, so x, y, z or z by x are equivalent. So that is either r x, y, z, theta 1, theta 2, theta 3, r z by x, theta 1, theta 2, theta 3. So whatever it may be, so order. So these are the identical transformation matrices, rotation matrices. So now let us compare those rotations about y-axis, and the other axis, theta 1, theta 2, theta 3, by wrist motions, which are yaw, pitch, roll. Okay. సో ఇక్కడ మీరు పిచ్ wrist మోషన్స్ ఏంటంటే మనకి యా, పిచ్, రోల్ అనేవి ఇవి త్రీ wrist మోషన్స్. ఇవి యా అన్నది ఎప్పుడు అబౌట్ ఎక్స్ యాక్సిస్ మనకు రొటేషన్ ఉంటుంది. అది పిచ్ అన్నది ఎప్పుడు అబౌట్ వై యాక్సిస్ రొటేషన్ ఉంటుంది. అలాగే రోల్ అనేది అబౌట్ జెడ్ యాక్సిస్ ఉంటుంది. సో వీటిని మనం అక్కడ వెక్టర్స్ కింద మాట్లాడుకున్నాం. సో జెడ్ యాక్సిస్ ఆల్వేస్ అప్రోచ్ వెక్టర్. సో వై యాక్సిస్ ఈజ్ ఓరియంటేషన్ వెక్టర్ and x-axis is normal vector. Okay, so this is represented as RPY. So where RPY is the about z-axis roll, about y-axis pitch, about x-axis y, RPY. So this above matrix, so it is also you can write. So this is equal to R P, R R suffix R P Y of theta 1, theta 2, theta 1, theta 2, or theta 3, theta 2, theta 1. So roll, pitch, yaw. So this is the value. Okay, so roll, pitch, yaw about R, about roll, about z-axis, about y-axis, about x-axis. సో ఈ సింబల్ కూడా మనం ఈ మ్యాట్రిక్స్ కి యూజ్ చేస్తాం. ఎందుకంటే ఫైనల్ గా మనకి మనకు కావాల్సింది ఏంటంటే ఆ వ్రిస్ట్ మోషన్ కి రిలవెంట్ గా మనకి ఈ రొటేషన్ మ్యాట్రిక్స్ అన్నది కావాల్సి వస్తుంది. కాబట్టి దాంతో కంపేర్ చేసుకుంటాం ఫైనల్. Okay, so here Euler angle representations. Euler angle representation. So ikkada the difference I will tell you in between the difference in between fixed angle representation, Euler angle representation. So main ga difference మీరు అర్థం చేసుకోగలిగితే ఓకే. సో ఇది మీకు క్లియర్ గా అర్థమవుతుంది. సో ఇంతకు ముందు నేను ఎవ్రీ రొటేషన్ అంటే 1, 2, 3 రొటేషన్, ఫస్ట్ రొటేషన్, సెకండ్ రొటేషన్, థర్డ్ రొటేషన్, ప్రతి రొటేషన్ ని రొటేట్ చేయడం జరిగింది. అది గుర్తుపెట్టుకోండి ఒకసారి, మీకు క్లియర్ గా కావాలి చూడండి ఒకసారి. ఫిక్స్డ్ యాంగిల్ రొటేషన్ ఒకసారి చూడండి, ఆ 3 ఫిగర్స్. సో ఈ 3 ఫిగర్స్ లో మనం చూసింది ఏంటంటే రొటేషన్ అయితే చేస్తుంది. సో రొటేషన్ ఫస్ట్ లో ఏం చేసాం, అబౌట్ ఎక్స్ యాక్సిస్ చేసాం, θ1 చేసాం. అప్పుడు మనకి 2' ఫ్రేమ్ వచ్చింది. ఓకే అండి. సో 2' ఫ్రేమ్ వచ్చింది. నెక్స్ట్ ఈ 2' ఫ్రేమ్ ని రొటేట్ చేస్తున్నాం, అబౌట్ వై యాక్సిస్ చేస్తాం. అబౌట్ వై యాక్సిస్ అంటే ఫస్ట్ ఫ్రేమ్ యొక్క వై యాక్సిస్ ఏ పొజిషన్ లో ఉందో ఆ పొజిషన్ నుంచి రొటేట్ చేస్తాం. సో రొటేట్ చేసినప్పుడు మనకి 2" ఫ్రేమ్ వస్తుంది. సో 2" ఫ్రేమ్ వస్తుంది. అలాగే సో థర్డ్ కేసుకి వెళ్తే అబౌట్ జెడ్ యాక్సిస్ మనం రొటేట్ చేస్తాం. ఏ ఫ్రేమ్ రొటేట్ చేస్తాం, 2' ఫ్రేమ్ రొటేట్ చేస్తాం. అబౌట్ జెడ్ యాక్సిస్ 2' ఫ్రేమ్ ని రొటేట్ చేస్తాం. చేసినప్పుడు మనకి అది ఫైనల్ గా డెస్టినేషన్ ఫ్రేమ్ కి రీచ్ అవుతుంది, UVW. ఓకే, ఆ విధంగా. ఇప్పుడు ఆయిలర్ యాంగిల్ రిప్రజెంటేషన్ ఎలా ఉంటుంది అన్నది చూద్దాం. చూడండి ఇక్కడ the moving frame, instead of rotating about the principal axis of the fixed frame, so instead of rotating about the principal axis of the fixed frame, so the moving frame can rotate about its own principal axis. Okay, so this is the case Euler angle representation. అంటే అక్కడ మూవింగ్ ఫ్రేమ్ యొక్క ఓన్ ప్రిన్సిపల్ యాక్సిస్, అబౌట్ ఇట్స్ ఓన్ ప్రిన్సిపల్ యాక్సిస్ నే బేస్ చేసుకుని రొటేట్ అవుతుంది. సో ఇంతకుముందు అన్ని ఫిక్స్డ్ ఫ్రేమ్ ప్రిన్సిపల్ యాక్సిస్ అబౌట్ ఫిక్స్డ్ ఫ్రేమ్ ప్రిన్సిపల్ యాక్సిస్ నుంచి రొటేట్ అయ్యి, బట్ ఇక్కడ ఆ మూవింగ్ ఫ్రేమ్ ప్రిన్సిపల్ యాక్సిస్ నే రొటేట్ అవుతుంది అన్న పాయింట్ మీరు గుర్తుపెట్టుకోవాలి. చూడండి ఇక్కడ 3 ఫిగర్స్. సో ఫస్ట్ లో ఏమవుతుంది, అబౌట్ జెడ్ యాక్సిస్. ఇక్కడ అబౌట్ జెడ్ యాక్సిస్ తీసుకుంటున్నాడు ఫస్ట్ కేసు. మీరు అదొకటి క్లియర్ గా అర్థం చేసుకోవాలి. ఇందాక అబౌట్ ఎక్స్ యాక్సిస్ ఉంది, ఇక్కడ అబౌట్ జెడ్ యాక్సిస్. అంటే సో లాస్ట్ నుంచి ఫస్ట్ కి వస్తుంది అనమాట. సో రివర్స్ కేసులో అబౌట్ జెడ్ యాక్సిస్. సో అబౌట్ జెడ్ యాక్సిస్ రొటేషన్ అవుతుంది. సో రొటేషన్ అయినప్పుడు మనకి 2' ఫ్రేమ్ వస్తుంది ఇక్కడ. ఓకే, సో 2' ఫ్రేమ్ కి రీచ్ అవుతుంది బై అన్ యాంగిల్ θ1. ఇప్పుడు నెక్స్ట్ సెకండ్ ఫిగర్ లో ఏం చేస్తామంటే మన సెకండ్ యాక్షన్ ఏంటి, అబౌట్ వై యాక్సిస్. ఇక్కడ అబౌట్ వై యాక్సిస్ అంటే ఇక్కడ 2' ఫ్రేమ్ యొక్క వై యాక్సిస్ ఏంటి, V'. ఓకే, సో అబౌట్ దిస్ V' యు రొటేట్ ద ఫ్రేమ్ బై అన్ యాంగిల్ θ2. అప్పుడు ఏమవుతుంది, మనకి 2" ఫ్రేమ్ కి రీచ్ అవుతుంది. అంటే U', V', W'. ఓకే, ఆ ఫ్రేమ్ కి రీచ్ అవుతుంది. ఓకే అండి. సో దిస్ ఇస్ సెకండ్ యాక్షన్. సో థర్డ్ యాక్షన్ ఏంటి, అబౌట్ ఎక్స్ యాక్సిస్. అంటే ఇక్కడ మనకి ఆయిలర్ యాంగిల్స్ లో అబౌట్ u axis rotation ఉంటుందండి. About u అంటే u double dash about so this u double dash about this u double dash మనకి రొటేషన్ ఉంటుంది by an angle θ3. సో u double dash u ఇక్కడ చేసినప్పుడు మనకి ఫైనల్ ఫ్రేమ్ 2 ఫ్రేమ్ కి రీచ్ అవుతాం అన్నమాట. సో ఇప్పుడు రొటేషన్ మ్యాట్రిక్స్ ని ఎలా డినోట్ చేస్తామంటే చూడండి కింద okay. So equivalent rotation matrix 1R2 or the RWVU θ1 θ2 θ3. So this is 1R2 dash. So 1R2 dash is the rotation about W of θ1. So next between frame 2 dash and 2 double dash ఈ రెండు ఫ్రేమ్ల మధ్య రొటేషన్ జరిగితే అది about V dash by an angle θ2. So between frames 2 double dash and 2 ఆ రెండిట్ల మధ్యన రొటేషన్ చూస్తే that is RU double dash R3. So this is altering of the rotation. It is left to right ఉంటుంది. మీరు అది గుర్తుపెట్టుకోవాలి. సో ఇక్కడ ఆర్డర్ సో ఫస్ట్ యాక్షన్ లోనే రాస్తాం, సెకండ్ యాక్షన్ లోనే రాస్తాం, థర్డ్ యాక్షన్ లోనే రాస్తాం. అంటే ఆర్డర్ వచ్చేసి లెఫ్ట్ టు రైట్ ఉంటుందండి. అంటే 1 2 3 ఫస్ట్ యాక్షన్, సెకండ్ యాక్షన్, థర్డ్ యాక్షన్. బట్ ఇన్ ద ఎర్లియర్ కేస్, ఇన్ ద ప్రీవియస్ కేసులో చూస్తే మనకేంటి లాస్ట్ యాక్షన్ ఫస్ట్ రాస్తాం, ఫస్ట్ యాక్షన్ లాస్ట్ రాస్తాం. అదన్నమాట. అది దట్ ఆర్డర్ ఈస్ రైట్ టు లెఫ్ట్. Okay, please 1 or 2 minutes, please. I will conclude. Okay, so this is the matrix. So both are identical అండి. మీరు ఆయిలర్ యాంగిల్ రిప్రజెంటేషన్ లో చూసినా, ఫిక్స్డ్ యాంగిల్ రిప్రజెంటేషన్ లో చూసినా, సో దిస్ ఓవరాల్ రొటేషన్ మ్యాట్రిక్స్ ఈస్ ఐడెంటికల్. మీరు ఏ కేసులో ఏ మెథడ్ ఫాలో అయినా మీకు వచ్చే మ్యాట్రిక్స్ అదేనండి. మీరు ఒకసారి చూడండి, అబ్జర్వ్ చేయండి. ఇక్కడ వాల్యూస్ C2 C3 C2 S3 మైనస్ S2 S1 C2 C1 C2 సేమ్ వాల్యూస్ అక్కడ కూడా ఉంటాయి. చూడండి ఒకసారి. ఫిక్స్డ్ యాంగిల్ రొటేషన్ C2 C3 C2 S3 minus S2 S1 C2 C1 C2. ఓకే, ఆల్ ఆర్ ఎలిమెంట్స్ ఆర్ సేమ్. రెండు కేసెస్ లో మనకి రొటేషన్ మ్యాట్రిక్స్ అన్నది సేమ్ వస్తుంది. సో ఈ ఫండమెంటల్ మీరు అలా గుర్తుపెట్టుకుంటే మంచిది. ఓకే, సో దీని మీద ఒక ప్రాబ్లం ఉంది. ఐ విల్ డిస్కస్ ఇన్ ద నెక్స్ట్ క్లాస్. ఓకే, దట్ ప్రాబ్లం. Okay, so today I will forward this material. You study that problem. You may understand that problem. Very mathematically, very simple problem. Okay. Okay. Thank you very much. So, do you have any doubts? You will ask in the next class. So, thank you. I stop the lecture here.